All right, everyone. So today we're going to be taking a look at assignment 3. Just like assignment 2, it's going to be open for a week, and uh, it will be 60% of the grade for following along with the documents and just being walked through that portion. Today we'll be just looking at the documents themselves, the topics they cover, and kind of seeing a little bit more in depth on how that's supposed to be working and a couple of things to look out for while you are working through them. So assignment 3 has 8 parts to it. The very first one is talking about interface communication. So up until this point, we've been using what is called direct communication, where we actually get that exact, get a reference to the object and then cast it to its exact type to actually call functions to it and things like that. And that's fine in most cases, but there are certain cases where you don't necessarily want to use direct communication back and forth. So we'll be taking a look at that right now. One of the problems with that, and I have three different projects open just for a couple of examples. So right here is where we left off from assignment 2. So this is assignment 2 with all the documents done. And we can walk around, shoot, reload. All the pickups are doing their thing, and even kill the other character. As well as if I hit the other fires, it'll kill the character we control. So right now, we are using direct communication in this. And what that means is that our blueprints, when we're accessing something, for example, our base character is telling our animation blueprint what animations to play, and then our animation blueprint, when it gets to those certain parts in the animation that it needs to tell the player to do something, such as the notifies when it's ready to fire and when reload is finished, we're getting a reference to that character, casting it to specifically our base character, and then calling a function directly from it. What this does is add a reference of the base character inside the animation blueprint. And that's generally fine if that communication was only one way. The problem is our base character needs to know about our animation blueprint in order to tell it when to switch animations and to call these different play functions. So that actually is a problem. If we take a look at the reference viewer, we can see how things are talking back and forth. So I'll do a reference viewer on our base character. And on the right side is all the things that our base character needs to know about. On our left side is all the things that know about our base character. So what this means is when we click compile on base character, before it can actually compile that base character, it needs to compile any of its dependencies on that right side. So it'll go through and say, all right, well, let's try and compile our animation blueprint before we can compile our base character. And that one needs to know about all the different animations that we have, standard macros, which is just like the plus plus and minus minus things. And then it gets to this one and is like, all right, well, let's compile our base character before we can compile our animation blueprint. And what happens is it keeps cycling through this infinitely. Now, Unreal, the blueprints themselves, have a bit of protection on that. It'll detect that it's just constantly referencing each other. So when it does detect a loop like that, where they're both referencing each other back and forth and need to know about each other, it just says, all right, well, instead of making sure that like our animation blueprints compiled before our character, we'll just use whatever the last version was compiled. And that's generally okay in most cases. The problem is when you're working on like a team and there's a lot of people adding new things to the different classes and stuff, that order of compiling starts to stack up. So let's say you had a teammate in your character adding a bunch of sounds and another teammate in your animation blueprint adding some new animations or new functions for that. And they compiled their base character first, whereas you compile your animation first, what you'll actually see is, even though it's the same code on the two different computers, based on that, when the first one was compiled, maybe sounds won't play, maybe the animations won't play, things like that. So we really want to get rid of this circular reference right here. And we can do that by getting rid of the direct communication. So right now, base character knows about animation, animation knows about base character. What we want to do is change it so that one of them just sends a message or something like that to the other. And the easiest route to do that, since our character telling it which animation to play is going to happen quite often, it would be easier to do this on the animation blueprint. So rather than having our animation blueprint directly reference and doing the cast, we can change that to go through what is called an interface. So an interface, when you right click and actually create it, and this is under the Blueprints tab, Blueprint Interface, we're going to be creating an interface for our character's functions. So we'll call this I_character. I for interface and character because it's going to be replacing some of the character functions. When we open this up, you'll notice this graph is read-only. That's because interfaces themselves are not, they can't actually define what the function does. The only thing interfaces do is define what functions they have, what the inputs and outputs of those functions are. I can't even add any variables or anything like that, just functions. And this concept of interface is not just an Unreal thing, it is just coding specific. C# also has it, which we'll be talking about later in a future class in about 4 months when you hit game development. And what we can do in here, so read-only, keep that in mind. Interfaces are always read-only. So we'll name this function, and what we would want to name it, well, we're going to be moving our current functions that our animation blueprint is calling directly, and we're going to move those over to the interface. So we have a shoot weapon and reload weapon. Those are the only two the document's added, but if you added like another one to say end movement or end attack or something for the attack finish, you'd also want to switch that one over. But right now we just have the two, shoot and reload. We'll go to our interface. We'll rename this first function that it just gave us as a template, and we'll call this ready to fire. We'll need another one, and we'll just call this one ready to reload. As far as the inputs and outputs, since we already have those functions available, we can check out what those inputs and outputs are. There's nothing other than target and no outputs, no inputs, no outputs. That makes it pretty straightforward. Once we have this, we can compile this interface. And then we need to go to our actual class that we're going to be adding this interface to. That's our base character. So inside here, under the class settings, you can tell it which interfaces you'd like this class to implement. We can then add the interface, and we just called it I, and what's up with my mouse? I_character. Once you've added that, you're going to want to compile again. And we can start defining those functions. So remember, interface just declares which functions it'll have, what the inputs and outputs of those functions are. But the actual, like, what happens when we're calling it has to be on the class that is implementing it. So we've told it to implement it. And as I mentioned, our animation blueprint, shoot weapon, and reload weapons are the ones that we're going to be replacing, moving those over to the interface? Well, we have shoot weapon and reload weapon right here. If we want to get access to the ones from the interface, we can just search for, we called it ready to fire and ready to reload. So there's a couple of options. We can immediately call the function. Well, we haven't defined what that function does. So just like when we were adding the older functions, we want to make sure that we're adding this as an event. So when it's ready to fire, rather than having that, we'll just, rather than having the shoot weapon, I'm going to actually get rid of the shoot weapon and use this one from the interface. When something is added on the event graph that is from an interface, we get the actual interface icon in the top right corner, and it will say this is from the specific interface. We can also replace the reload weapon with the ready to reload. Give this a compile, should be good. Sorry, back over here. If we take a look over at our animation blueprint, we see we got rid of the one called shoot weapon and reload weapon. They're now in the interface. So one great thing about the interface, though, is we no longer need to cast to a specific type and add a reference to the other blueprint. We can get rid of that and just send this owner, without having it a specific type or anything, a message for ready to fire. And this one is the ready to reload. So now, if we compile this, compiled all right. In game, let's make sure that everything is still all working. So still shooting, still reloading, just like normal, and they're both working. So from an in-game perspective, we don't see much happening. But from a code structure-wise, our base character still references our animation blueprint, but our animation blueprint does not know about our base character. It just sends this message to this object. And if this object happens to be a type that actually implements that interface, which it is in this case because it's our base character, then it will handle that message. If we send it to, let's say, like our HUD, or another object like our game mode or something, the message will just go ignored. So it is a nice way of just safely saying, hey, I don't care if you handle this message or not, just I'm going to try and call a function that says ready to fire. If you do implement that, then we'll handle it. If you don't, we'll just ignore it. So it's a much cleaner way of talking back and forth and just making sure everything's compiled and saved. Now, when we actually look back at the reference viewer, you see our base character does still need to know about our animation blueprint. And our animation blueprint needs to compile all that. And then it does know about the interface, but our interface doesn't know about anything. So it can actually finish compiling this, and then there's no more circular recursion happening and no issues about what was compiled first or anything. Are there any questions about how that interface gets added, how to add a function to this? We'll be taking a look at this a bit more on Monday as well.
Before, when we were casting to a type, was that just to make sure that it was the player who initiated the action?
So if you take like an object like this try get pawn owner and try and cast it, it gives you options for what types of things it can be cast to, because this type that it's returning is just a pawn, and pawn is just the basic thing from Unreal. So it's a very high level object. It doesn't have necessarily the added functionality of a character or specifically our base character on it.
Okay,
But
so
what
it wouldn't
casting
be
does,
not quite like in Unity when when you just like kind of call to a public object that you assigned or something and do get component or something. It's different, huh?
yeah, get component would be just get component. So for example, we have our base character and we have character movement. From pawn, I don't think pawn has any, but if we actually like get player controller or character, this is returning the player character class, which is still not our base character. But if we wanted to get movement component, we have those same get components and things from that object. But
Okay.
because technically components are the same actually back and forth between them. Same as if you're in the base character and we wanted the mesh component, we'd have to get that mesh component, get the socket location from the mesh in a C# script. Because dragging this in is the same as typing like get component mesh.
I see. So we had to cast to the base character in order to just access anything that's in the base character blueprint.
Yes, because base character is a child of character, which character is a child of pawn. It can cast down. It does what is called a downcast and gets the very specific type of that. So getting pawn, like I said, it returns pawn, and we know that this owner actually is a character and is our base character, so we can cast to it and it won't have any problems. But if I try and like even access like the get component, we'd have to actually type in by tag, by type of component, or by class, things like that, which is not a great way of doing that. And if we were to cast to our base character, also casts exist in C# as well. Same concept right there. Same concept, just you're given a value back, or when the cast fails in Unity, it'll just return null. Same concept here. If the cast fails, it'll just return none for this as base character. But now as this base character, we can actually see anything taking a base character object reference. So if we were to do, let's say, get health ratio is a function that we specifically added to our base character. And it is still accessing it on this object, but this object is not the right type to give us access to our base character information or functions, variables, things like that.
Okay, so it gives you the option to cast to base character because there are pawns in that we've placed in the world that have the base character class added to them.
Not added. So our base character, when we first created it, we went to a blueprint class, and this is where you actually select what base class you want to use. Actor is the most common base class for anything that you place in the world. A pawn is actually a child of an actor with some more functionality. The pawns can actually be possessed and receive input. A character is a pawn, but with some more functionality added onto it, like the character controller and capsule component, so it can move around. So we selected a character as our base class, and that's our base type that it has additional functionality on, and what we created a child of base character technically. So that's the same way we did with our pickups. Like we're actually creating a child of our base pickup anytime we wanted a new pickup type.
Okay, so the reason we're casting from pawn to base character is because like base character is kind of what like I don't know how to say it, a level up from pawn.
It's level down if you're
Level
thinking
down,
about it
okay.
as top down, like the parent of that class goes up, child classes go below. Yes,
Okay, okay.
it has everything the parent has with additional information for that specific type.
All right, all
So
right. And so like if something tried to get the pawn owner for a pawn that's not the base character, it would just fail the cast, right?
correct. If we had another type of character that wasn't a base character, it would fail that. So for example, I can show that real quick as a demonstration. This one's going to be simple dude, and spelled that wrong, but this is fine.
Do it.
Yeah. Let's throw a mesh on it. Simple dude's gonna be a gun mesh. And if we add that in our level and we went to, say, our animation blueprint, this is asking for the owner of this animation blueprint, which only our base character is using this animation blueprint. If we try and cast our base to simple dude, it will actually fail. So it'll print hello when it succeeds, print, and we'll print fail when it fails. So by checking that out, if we try and play this and we try and shoot, we'll see it is printing that fail because our base character is the one running that animation blueprint. So the owner is a base character. It is not the simple dude, even though it's simple dude is a type of pawn, type of all that. The specific instance that that character is using for the controller is not a simple dude.
Okay, so I guess the only time you'd be worried about a cast failing is if you had a blueprint attached to like more than one type of pawn, I guess.
No, not really. So for example, like casting is a great way to figure out what type of object that actual type is. So for example, our base character, well, yeah, let's do it on our base character. So our base character, when it overlaps with something, we'll have it check what type of actor the other actor is. We could say cast to, let's see if we're hitting our pickup damage. If we are hitting it, print damage. If it fails, then we could try and cast again. Cast 2, and we'll go with the other pickup type. That'll be easiest since those are the things with collision. If this one succeeds, we can print string saying max ammo. And if it's neither one of those types, we could check, because this, what this overlap's returning is just another actor. Actor is that base type that, and any object placed in the game will really be like an actor other than some brushes that we'll talk about in a moment. But this is a real quick way of seeing, is it this specific type? But it's also not a great way of seeing exactly like certain object types and things like that. It gives us the interface to actually call functionality from the type. But if you don't want, like now, our pickup damage well, our base character needs to know everything about that pickup damage type and is adding a reference to it because it's actually trying to get the interface of those functions, of those variables from it. So you, and let's actually just test this out. So we have this one printing for when we hit damage, this one printing for when we hit max ammo, and we can do one more. We can see cast 2, and let's go, did I call it base projectile? So we'll have one for all the different types that have some basic collision stuff. Print string.
Okay. So when it comes to casting to the base character, um, we don't have to check for it for anything else because that's the only kind of character in the level, right?
Yeah, yeah, like we pretty much assume this is always going to be correct because we know we've attached this animation blueprint. We've told our mesh specifically to use that animation blueprint.
Right. Okay. Okay.
So even if it was failing, it would be perfectly fine if we did try and have our simple dude use that blueprint. Well, we might see some bad things happen, but we'll go ahead and try that. Okay. So technically this is character over here that is using that animation blueprint, just never being told to play any of those animations because it doesn't do anything. And if we check out our prints, so watch in the top left for any prints, as well as like we can open up our output log, move that over here. And when we hit this, we see it printed that type because the cast succeeded for picking up a max ammo.
Hmm.
If we hit the fire, we get the print for damage because, and we added that right here. So the damage, if it does succeed, it is going to print that damage. If it doesn't, then it'll check, was that actor that we hit an actual max ammo? Yes, it prints max ammo. Was the actor that we hit not a max ammo, but was it actually a base projectile? It should print projectile. I can check that out by shooting the other character. And it does print projectile.
All right. Yeah, it makes sense now. I guess I just had to see the cast like go into a fail case in order to really understand like how it was working.
Okay. Yeah, ideally you would have known what cast was before this class, but didn't get that worked up in the program earlier, I guess.
I've been doing programming for a long time, but like outside of games, like the only thing I really ever cast to was like different variable types.
Yep.
Like
Technically,
typecasting.
all of these are typecasts. It's the same thing. Just the type is from a game object hierarchy.
And somehow for me, visual scripting doesn't translate over to actual code too well in my head. I don't know why.
It's either hit or miss. The more you work with it, the more it'll start to flow and you'll see it easier. One big thing, like if you're used to doing like an object dot, a lot of times organizing it like that can help so that you see the exact
Yeah.
object that it's being targeted from, then calling the
Now that you
function.
say it, I have been actually like kind of stacking stuff like that just to give
Yeah.
myself a visual
So
like representation.
it's all dependent on what you're used to because some people get thrown off by the zigzaggy lines. So depending on how you really want to orient it is, just go with what makes the most sense to you. All right, so that was the interfaces casting. So moving on.
Yeah, thanks for that.
No problem. Glad to explain any topics that you want more information on. And 1 second, let me double check this. Okay. So part two, we'll be starting on adding a crosshair. So part two will be adding the crosshair material itself, just getting that rendering to the screen, not really interacting with anything yet. Part three will actually get it to change colors when it detects that it's over an object. And part four will finally get the projectile that we're shooting to actually aim at what we're looking at, rather than just shooting straight out of the character. So these three parts are kind of all linked. We're just doing them step by step, slowly adding more functionality that's easily testable. So taking a look at how this works, and we'll get to this. Nope. We'll go, sorry, first. In here, this will be adding the HUD stuff. So our HUD, we're creating a new crosshair material and stuff, and then we're drawing that material when our HUD says when it can draw, centering it on the screen, and we're doing some extra math to actually get it to draw the center of the crosshair on the screen. One other thing is, while this is running, every frame, we have our HUD do a line trace. So you guys are familiar with ray tracing in Unity. Well, same concept here. Our line trace itself will actually be doing a line trace, because ray tracing is technically an infinite line, whereas line has the start, or raycast, yes. So you have a start and an end, which is actually a line, not a ray. But what we do is ask our game, where is our reticle? And we're getting a ray from our character, or wherever that crosshair is on the screen. We're shooting it out into the world. We get a position and direction. And what we do is a little bit of math right here. We're just storing the direction into a variable for use later. We're taking the original position of the ray, the starting position, and that'll be our start position for our line that we're casting. Then we take our position plus our scaled direction to shoot the ray out into the world. Our do line trace is the one that's actually doing the trace itself, or raycast. And there's a couple of excellent options on here. The draw debug type is really nice built-in functionality for you. So you can actually say, like, let's draw a debug type for one frame. So while you're working on this, with that draw debug type set to one frame, we're actually getting a line shooting out right over that reticle. So this is great, because if we actually grab our mouse back and eject, or just press F8, when you eject while you are playing, you can move outside of your character controller in just the normal level movement. But our game's still playing, so we're actually doing anything our game does. We can possess again to actually start possessing that again. So if you are having issues where, like, you're hovering over your character and it's not highlighting, one of the first things to check is that actual cast that it's doing with the debugging information, where that's drawing the line, is it's coming from the center of the reticle. And we'll eject from our player, and what we can do is see, is it actually detecting the hit? And it's this little red line that'll shoot until it detects a hit. It'll actually put a little square that's red where the hit was detected. Then the rest of the line will be green. So that's really useful for figuring out if you got that math wrong or something screwed up in the HUD. So this is just trying to debug, is that ray calculated correctly? So for example, if I mix up some of these inputs and do something like that, and we start playing, we'll see, that was really bad. I didn't mean to do position for that one. Let's just do direction times that. And so just mixing these up a little bit. If those connections are bad, we'll see it looks mostly correct, but actually as I get farther away, we'll see that ray is coming from the center of the cursor, but it's going out at awkward angles. So something's wrong with that math if you do notice your ray is not detecting a hit right over the center of the cursor. So we'll just reset this to the proper connections. And that's just a quick way of debugging like that math there, making sure it is shooting the ray out correctly. Then what we're doing is taking the information, the out hit. So this would be like your hit result that you have to create for the line cast, or for the line ray trace or ray cast. I believe it's called ray cast hit, that you have to create a structure and then pass that in as the variable for when you're calling raycast in Unity.
Yeah.
And then you're given a bool back whether it did hit that or not. And we just store these in some variables for use later. We then are doing a branch, whether it hit something or not. If it did hit something, we make sure that the actor that it hit is valid. If it's not valid, and we have, finally, the part where we're setting the actual parameter on the material we made. We created a parameter called color. And so we're saying set that parameter color to our danger color or safe color. So very important that you do remember to type this name in when you are setting that up. It has to match whatever you named it inside the material itself. The other thing we're doing is, once again, using tags. So if this did hit something and it is a valid object, so we are hitting an actor that is something in the world, we can check, well, is that actor a base character or is that actor a target? So these are the two things that we'll say take damage. We haven't talked about the targets yet, but we will in a couple minutes. We just say either one of those. If either one of these are true, then we can set it to a danger color, meaning it'll turn it red. So our danger color is red, safe color is cornflower blue. And that's all that this do line trace should be doing, just doing the line cast, saving the cast stuff into variables, and setting the colors. Then, so we see it does change when it actually detects that hit and is over something that it can damage. So these targets are the ones that we'll talk about in a couple moments. One other thing I would like to show is, while this is playing, we pull out our HUD graph, and yeah, let's make this bigger. And we wanted to actually see which path this is taking. There's something up here called the debug filter. The debug filter actually allows you to select the one from the game that's actually running. We currently only have one HUD, so it's not a lot to choose from. And we can see that execution path. Let me just drop this down a little bit. So we can see right now, it's setting it to safe because it did hit something. The thing we are hitting is valid, which is the floor. And the floor does not have either one of these tags, so it sets it to safe. If we aim up here at some of the level geometry that we put in the level, Shift F1, we can see that it does take a different branch. This is that not valid branch. So still setting it to safe because we're over something that we can't damage. If we go back, and we can actually watch exactly which path this is taking. We are over one of the targets right now. So it does actually detect that it is valid. And this time it's going through the true branch. We see it changing and which path it's taking based on what item we're actually over. So this comes in really handy when you're trying to figure out, why is it changing at the wrong time? what object is it detecting? Are all of these paths actually setting a color, whether it's safe or danger? Just something to keep in mind when you are working through that portion. All right. So moving on to the next part. Part 4 is where you actually get the bullet to shoot towards that reticle. So the way we set it up before, our base character, when it was ready to shoot, it just shot it and then said, whatever my forward direction is the direction it's going to shoot the bullet. Down here, we have more information now. We have information that we can ask our HUD. We're going to use an interface since we already have our HUD calling functions from our base character to get the values of the ammo ratio and health ratio and the player name and stuff to display all that. We want to make sure that our character doesn't need to know about the exact HUD type that we're using. We're using just a generic HUD, and we're just sending it through an interface to get information out of that HUD. So we're getting those variables that were stored when it did the line trace. And we're saying, did we hit something? If the hit result was true, then we have something to aim at. If it was false, then we can use the direction that we stored from just whatever that D project was giving us. But if it is true, we do hit something, we want to calculate a vector towards that point that it's actually hitting. So we're doing a subtract to calculate a vector. And what we want to do to get a vector from one point to another, we want to do destination minus source. So if we're spawning this object from the shoot location, this would be considered our source. We then want a direction towards the impact point. So we're doing impact point minus the shoot location and converting that for our rotation that we're passing in. So that gives us the ability to make sure that when we shoot, and I usually like to do this over here so we can demonstrate it. If we're aiming way off into the distance, it can shoot and slowly approach that very far distance. If we're shooting at something close, we'll notice it takes a drastically different route because when things are close up, it is a perspective view. The bullet's spawning from the hand, which gets to be like right about here. When it shoots at something close, it has to take a much sharper angle and make sure it's still actually hitting what we're aiming at. So the further it is away, the further it actually has to, the different angle it has to shoot at. That's why we're doing the raycast and making sure that it goes towards the point that we're aiming at from a perspective view. Any questions about the aiming or the HUD line trace? Nope. Okay then. So moving into the next part, this one's going to introduce jump and double jump along with some geometry editing. So the geometry editing is something that's just built into Unreal. They have some brushes to make some simple geometry. That's what this little ramp is and this little box is. One thing I do want to mention about this section is this is 4.25. They did change the layout a little bit. So this one over here is just called place actors. The modes has actually changed over here. So to go to brush editing, you have to go through this modes instead of the modes that previously was the place actors. And in here, you can select the different faces, move them around to create different shapes, things like that. Just some quick stuff. This is really just for blocking out things. It is not not nearly as powerful as something like Pro Builder, but gets the point across to just create some basic shapes and block out the level before you go in and replace it. There's extrude and a lot of different options on here. As far as the extent that we expect you to do it in this class, just some very basic blocks and things like that. Don't worry about any textures or anything. There are some links to some more in-depth tutorials for the document, but for right now, just make sure that it's all functional and things. So I'm going to switch my mode back here. And what I was referring to about the layout changing, that's why I have this third project here. So here's 4.24. The modes was all combined just in this one tab over to the left. So the geometry editing is that far right one. So they did change it a little bit. So I just wanted to make sure that that was covered. As far as the jump and double jump. So we have jump and then double jump. So after you jump in the air, you can also push the character up. We'll be taking a look at how to call that from our base character and adjust some of the settings. We also, not in the next part, add in, if we're falling from a big enough height, we'll take damage. So jump and double jump, mostly focused on getting the animations all set up. As far as actually setting the jump up itself, that's something built into our character movement already. We can just adjust certain values and have that functionality real easy. Part 6 is targets. So targets, as I mentioned, are just going to be these things in the level that are just a basic cube. And the reason we're creating these is to show why we've wrapped up that killable component. So rather than having these add their own health system and everything like that, we have killable, which already tracks health and stuff. So these, when we shoot them, take damage and do actually respond when they're shot and receive damage. And that's really simple. This is the entire script right here. All it's doing is saying we added killable, so it does track its health and says what happens when the target gets destroyed. Well, it's going to destroy the actor.
So it's almost like the other base character. When we hit it 5 times, it dies, but it's not really destroying him. This one is actually destroying targets.
Yeah, this was mostly just showing like that killable component rather than adding another on take any damage and some health variables all here, duplicating all that code and work that we've done before. We can just say, well, yeah, I want this to respond to health as well, and add that same component that our base character has.
Okay.
And how we can adjust the health is because we can set that right here. I have them just set to 1 health each by default, and those are public, so we can change that from here. And we can also even change it per instance. If we select one of these cubes and go to the killable, let's say this one's going to take 3 hits to kill without editing any scripts or anything. We're just changing the instance and the level. We now have different health targets. Moving on from the targets itself is basically how we're going to set up the end goal of this game. So the goal of the game will be to destroy all of the targets. So with that, we go into how to actually track objects in game. So up here in the top right, you may notice a new element on our HUD. It says 0 of 2. The second number on the bottom is the number that were placed in the level. That first number is the number that you've destroyed. So think of this as your objective tracker. You've destroyed 0 of 2. If we go ahead and destroy one, we see that number update, letting us know that one of them's been destroyed. And when we destroy the other one, that would be considered our win condition. Now, we're not adding that till the next assignment, but this is getting the groundwork set up so that we are actually tracking the objects when they get destroyed, things like that. The way we're doing that is through our game mode. So the game mode is the blueprint where you basically set the rules of the game up. So tracking the number of targets destroyed would go here. What we do is get a reference to our HUD so we can talk to it. Then we're using get all actors with tag. This is similar to find objects with tag in Unity or something along those lines. And we're specifically saying we want to find anything that's been tagged with the target tag. We're then looping through each one. And for each one of them, we're saying we want to know when it's been destroyed. When that one gets destroyed, we're going to call remove target. So it counts that target number down. Once targets actually reaches 0, and we can see it starts out at 0. If we're playing and actually debugging, well, I'd have to actually hit a breakpoint, but well, come on. Let's add a breakpoint here and destroy one of those targets. Oh, and it started a new window. Dang you. As we hit that, we see it pause the game. We'll grab our mouse back, Shift F1. We're paused on that event because it detected, hey, one of these targets was destroyed. We can step over, we see it's gonna say our number of targets, which is now got a value of 2. That got counted up for each target when the game began. It's gonna subtract that and then let our HUD know to add to its destroyed count. So this is how it actually increases that top number. We can step into that, make sure that it is going to our HUD, and here's where that number gets changed and incremented. And stepped into the increment, we'll step out of that. And this is where it's telling the projectile to destroy itself. It already did the damage and destroyed the target already. Step out and it's back to playing. All right. So that pretty much wraps up the target content. Just going to remove that breakpoint in case I play again. And next up, part 7. So we're going to add a hurt animation, but we're not going to add it like we've added the other animations where we just turn on a bool and have it go to that specific state. Hurt animation is something that's too important to just not play or play and interrupt all the other animations. So we're going to take a look at how we can blend this in with all of the other animations through a montage. So if we take a look at what this looks like, if we take damage while we're running, we notice those feet are still running, but that upper body did like a yank back, like it got hit in the shoulder. So it plays it while it's running, as well as if we shoot that, we see that same reaction on the other character. It's actually blending in to whatever animation it's currently playing. Going to our animation blueprint. So rather than this one being something on the graph, and don't like the fact that I have so much stuff open. Our state machine, we added the jump as a sequence and things like that. And then our hurt animation is nowhere to be found on here. But if we do check is hurt, we see our character does play that hurt. That's because this exists in the actual animation graph. What we're doing is running the state machine like normal, But rather than having that go directly to our output, we're going to store whatever pose that spits out. So with that stored pose, we then do what is called a layered blend per bone. Now this allows us to select certain bones in the hierarchy to actually blend to. The way we set this up in here over on the right side with this node selected, we actually set up these things called branch filters. We set up specific bones for it to start blending. So from spine 0, 1, which is like right here and up, it will actually blend. We then cut it off at the upper arm L. So upper arm L is this shoulder bone right here, and lower arm R, which is pretty much the elbow over here. If we wanted to change this, we're saying -1 when we want to cut it off and stop blending between there. One thing that you might want to consider is if you did swap the animations for the gun animations, you would probably want to change this from like lower arm R, so blend to cut the blend off sooner so it's not affecting where that arm is as much, because it will cause some odd issues of like the lower arm going through the body and the gun getting all messed up. But just something to keep that in mind of like where it's blending. That's really kind of up to you where you want to cut it off at. If you want it to play on the entire spine, you could go ahead and just leave those and not cut it off at all. And I believe is hurt. Yeah, so is hurt with the full animation is set up with the gun being held. If we do change that back to -1, to cut that off on the arms, we can, oh, got to compile, of course. We see that it's no longer affecting those lower arms and things like that. So that's just a couple of things to keep in mind about how this is all working. And it gets blended in, as I mentioned, to any of the other animations. So even if we're like attacking and taking damage, we still get to see some feedback in game that, yes, you just took damage, which is one of those vital feedback things that you need to get across to the player.
So did you only have those -1 values on like the upper arm of one side and the lower arm of the other side?
Yep, just showing you that you could cut it off wherever. As far as these bones that we chose to cut it off at, that was really just pick and choose one of the bones from the hierarchy. So looking at here, we
Oh,
just
so you
went
could
to,
do lower arm on both side or upper arm on both side.
yep, you could even cut it off at like, well, I don't want this finger to be blended and things like that. We're just giving you the basics of how
Got it.
that works. Yep. All right. So last part that we're doing for this assignment is getting a start on our game loop. So right now we're just always loading into that game scene and just playing straight from that level right in the game. We're actually going to finish this all off with a full-on game loop, but we're just starting this one at the end of this assignment. What that means is we'll be adding a new level, a main menu level. And let me close out of everything. So our main menu level has nothing in it. It should have nothing in it. And under blueprints, we're using what is called the level blueprint. We can open that up. And this level blueprint is the one that actually creates a menu widget. So since our menu itself is just a widget, a UI element, it doesn't need to be added or anything into this scene. We can just create it right at the beginning of play. We then set our input so that it can interact with the UI. We then add this to the screen using add to viewport. We also want to make sure that we have a mouse showing on screen, so we just make sure to set that to true. So if we play this, our main menu widget itself is just an image on the background, title, couple of buttons for play and quit. Quit, well, just quits the game. Play actually loads up our level. So we're getting a start on our level manager, and that's going to be held in what is called the game instance. So game instance is a unique class. It gets created when the application first starts and exists the entire time the application's loaded, not just per level or anything like that. Like our game mode is set per level. When we open another level, it actually unloads the game mode, creates another game mode specific for that level.
So game instance would be sort of like Unity's don't destroy on load sort of thing?
Yes, game instance, there is only one of them. It exists the entire time that your application is running. It's the first thing created, last thing destroyed.
Yeah, I got you. So it would be responsible for what, like switching between scenes and whatnot?
Exactly. That's where we're going to set up our level functionality, so it actually has an array of levels. We have the main menu in level 1. Obviously, that's a start to it. So we're just getting that first transition set up here. What happens is when you call a load next level, it increments whatever the current level is, then tells it to load that incremented level. In here, we're doing a couple of things. Very first thing is checking, does our array actually have enough levels to load the current one? If not, we'll print a message just giving us information like, hey, we might have forgotten to add it to the array, or our compare here is wrong, something. If it does, if it can be loaded, we then set the input to game only so that our game can actually take input, not just the UI with a cursor moving on screen. And we tell it to open that new level. We also create something called load main menu. This is just a placeholder that gets filled out and finished in assignment 4. So that's about it. As far as the actual content goes, were there any questions or anything you guys wanted to talk about a little bit more in depth? Got a few minutes still.
I think you addressed everything that I wanted to know about.
All right. And
Yeah, I'll probably run into some problems while doing this, but hopefully not.
when you do, just reach out on Discord and we'll be more than happy to get you back on track.
All right.
Alrighty. Then I'm going to go ahead and stop the recording.